Good afternoon. Today we are starting our quadrilateral review, and we're going to be looking at our different polygons and our different quadrilaterals. So make sure you have your calculator, your paper, and you're good to go. Okay, our first question today says, ABCD is a parallelogram with diagonals AC and BD that intersect at point P. If AP is 2x minus 1 and CP is 3x minus 6 and DP is 2x plus 3, find DP. The first thing I need to do is draw this picture so I know what I'm looking at. So first, when we draw a parallelogram, it goes in order around my vertices clockwise. So I go A, B, C, D. Then it says AC and BD are diagonals that intersect at point P. So right there, I do have it lined up correctly because AC and BD are my diagonals. Now it says that AP is 2x minus 1. CP is 3x minus 6. DP is 2x plus 3. What is this right here? Well, first of all, what do we know about a parallelogram and its diagonals? Correct. We know that they bisect. With the word bisect, we know that means they are congruent. So we know that AP is equal to PC. With that, we are able to find out what x is in our equation. So 2x minus 1 equals 3x minus 6. So now we're going to solve for x. So I have 5 equals x. With 5 equaling x, now I can come back and I know that BD bisects at P, which means that BP is congruent to PD, which means if I know PD, then I know PB. So if DP equals 13, that also equals BP. So BP equals 13. Sorry, I didn't know that was happening. All right, on number 2. Number 2 says, true or false, justify your answers. All isosceles quadrilaterals are parallelograms. Okay, well, first of all, isosceles quadrilaterals, first of all, what does isosceles mean? Isosceles means my legs are congruent. It means that my base angles are congruent. It means that my base angles are around parallel lines. That's what isosceles means. Now, with that, quadrilateral, we know, just has 4 sides. We've learned specific types of quadrilaterals, but a quadrilateral, by definition, is just a polygon with 4 sides. So, to be a parallelogram, what do we know? A parallelogram, first of all, has 2 pairs of opposite sides congruent. It has 2 pairs opposite sides parallel. It has our consecutive angles supplementary. It has my diagonals bisecting. And the last thing about my parallelogram is, think about it for a second, which one is it? I think I have them all, don't I? Oh, our opposite angles are congruent. I forgot which one it was. So, right away, can it be isosceles if my opposite angles are congruent? Because when we're looking at our parallelogram like this, we know that that's parallel and we know that this is parallel. We know that these angles are supplementary and these are congruent. Well, if these sides are congruent, that means these angles should be congruent as well, because that's what isosceles does. These angles are not congruent, they're supplementary, so our answer is false. Okay, number 3. Number 3, we have this beautiful figure that we're not sure how many sides it has. So let's count those first. And the little stars are degrees. So 1, 2, 3, 4, 5, 6, 7, 8. So my number of sides equals 8. And I want to find the value of x. Well, before I can find the value of x, I have to first find how many degrees is sitting here in this octagon. So I take my calculator. 6 times 180 is 1,080 degrees. Now with that, I'm just going to basically add this all up together, and it has to equal that much. So now I just pick a side to start with. I have 151 degrees plus 115 degrees plus 100, 123, 3x, x minus 33, 112, 5x minus 23 has to equal this 1080. So let's start adding all of our stuff up. So I have 151 plus 115 plus 100 plus 123 minus 33 plus 112 minus 23. So that's 545. I have 3x plus x is 4x plus 5x is 9x plus that 545 equals 1080. So 1080 minus 545 is 535. Divide by 9. And I get 59.4 repeating. You know how I feel about that. And it's an ugly fraction, so we're going to leave it as that right now. It's an ugly fraction, 535 over 9. But we just did the math enter on our calculator to figure that out. So it's an ugly little fraction, but we can certainly find out what x equals in the problem. You have to know the total number of degrees first. Okay. On number 4, it says for which value of x is the quadrilateral a parallelogram? So now we're pulling out our different properties of our parallelogram. We know that in a parallelogram, as we talked about a couple slides back, our diagonals do what? Correct. Our diagonals bisect. Because our diagonals bisect, that means x plus 6 equals 2x plus 5. So now I just need to solve for x. So x equals 1 or 1 equals x. For b, we know that based on a few slides back, that if it's a parallelogram, that our consecutive angles equal how many degrees? Correct, they're supplementary, which then means they're 180 degrees. So I know that 2x plus x is going to equal 180 degrees. So x equals 60. X is a value. X is not a degree. X is not the degree on that parallelogram. It's just the value of x. Number 5 wants us again to find a value of x. But now we're given all the exterior angles of what looks like it is possibly a parallelogram or a rhombus, but we don't know. All we know is it's a quadrilateral. So with that, how many degrees are in the exterior angles of any polygon? Correct. There's 360 degrees always for the exterior angles. Interior completely changes every time depending on my number of sides. Exterior is a constant, which is always 360 degrees. So I know that I can set up an equation, x minus 7, again that's just a little degree, plus 65, plus 80, plus 72 is going to give me 360 degrees. So now I just need to solve my equation. So I have plain old x. I have negative 7 plus 65 plus 80 plus 72. Now I need to subtract 360 minus my 210, and I get 300. That's not correct. 360 minus 210 is 150. So x equals 150. All right, again, we're finding the value of x. That's to be the theme this unit, finding the value of x. So with finding our value of x, this right here comes from that last section we did. It's the mid-segment theorem. The mid-segment theorem tells us that the mid-segment means he is the midpoint of each side. So my picture is not drawn to scale. The picture is not drawn correctly. Let's fix that picture. The picture should be 1 and 1 because he's a midpoint of that side, and 2 and 2 because he's a midpoint of that side. So that's the mid-segment. So the picture was not drawn correctly. So with it now being mid-segment, it's telling me that he's a midpoint of this side, he's a midpoint of this side, which means that he is parallel to these sides right here, which means then he's a trapezoid, not isosceles trapezoid, just a trapezoid. So with that, the mid-segment theorem tells me that the mid-segment, which is the 12.8, is 1/2 of my base 1 plus my base 2. And it doesn't matter who you call base 1 and who you call base 2. Typically they say the top is base 1, the bottom is base 2, but it does not matter. So my mid-segment here, 12.8, equals 1/2 of 4x plus 10x minus 2. So now I have options when I'm going to solve this right now. I could first clean up my parenthesis, distribute my half to both terms and move forward. That's very logical in my math. Or 2, I can go ahead and I can multiply the whole thing by 2 and get rid of my half, whichever one you're more comfortable with. If you're a distributor, then just distribute. Half of 14x is 7x, half of 2 is 1. Now it's a two-step equation. and it's an ugly number. 1.97 is rounded, but of course, you know me, Math Enter says it is 69/35. There are some ugly numbers on this review, but they are not ugly on your test. So that's all I know. And again, I just did Math Enter. This is a rounded decimal right here. That is the actual fraction right there. Okay, moving into problem number 7. It says, problem number 7 is probably missing some information here. It says, what is the most specific name for this quadrilateral? Well, right now it's nothing because there's no markings on it whatsoever. So let's go ahead and put a little bit of markings on here. All right, so now that I have some markings on this quadrilateral, let's say what is the most specific name for it? Well, first of all, it has one pair of parallel sides. If it has one pair of parallel sides, then he has to be a trapezoid. But more specifically, right here, my legs are congruent. How do I know they're my legs? My legs are my sides that are not parallel. Remember, this is my base. This is my base that makes him a leg and him a leg. So my legs are congruent, which then specifically makes him an isosceles trapezoid. The regular trapezoid doesn't have a lot of properties. It's just the one pair of parallel lines. The isosceles trapezoid has the extra properties because now that my legs are congruent, I know that my base angles then are congruent. The top base being congruent to itself, the bottom base being congruent to itself. So isosceles trapezoid is the most specific name for this figure. All right, number 8. On number 8, we are looking here at Mr. Kite. With here looking at the kite. The kite tells us a couple things we know. We know with the kite that the top is congruent to the top, the corresponding angles, and the bottom is congruent to the bottom. We know that the hinge between them, these two angles, are congruent. So E is congruent to C. We also know that these right here, my diagonals, bisect and 90-degree angles are formed because they bisect in the perpendicular. So I want to find the measure of angle C. So we know that CE are congruent. We know that this right here is a quadrilateral, which means how many total degrees are in it. Correct. We can either use the quadrilateral corollary or we can do again the n minus 2 times 180 to get that there's a total of 360 degrees in a quadrilateral. So I know that I can arbitrarily call this x. We know that he's x as well, so I can just form an equation. X plus 119.74 plus x plus 77.1 equals 360 degrees. Yeah, these are the degrees inside. So now 2x plus 196.84 equals 360. So 2x equals 163.16. Divide by 2. X equals 81.58. So the measure of angle C equals 81.58 degrees. 81.58 degrees. All right. This next one we're going to need a little piece of graph paper for. I'm going to put my little graph paper right here. So you need to get a piece of graph paper. Pause the video if you need to get some graph paper. It says the 3 coordinates of the rhombus A, B, C, D are given. Find the coordinates of point D. Well, first of all, I know that I have a rhombus. So what do I know about a rhombus? First of all, he's a parallelogram. With him being a parallelogram, we know that opposite sides are parallel, opposite sides are congruent. One pair of opposite sides is parallel and congruent. We know that our diagonals bisect. We know that the consecutive angles are 180. Consecutive angles are supplementary, which is 180 degrees. We know specifically when he becomes a rhombus. We then know specifically that now my diagonals not only bisect, they bisect my angles as well. We know that when it bisects my diagonals bisect, they also are perpendicular. So they form 90 degrees on the inside, which isn't going to help us for what we're doing here, but that's okay. So I need to go get a little ruler and draw a little coordinate plane. It's all in quadrant 1, so I kind of make it down here a little more. All right, so we know that A is 6'3", so 1, 2, 3, 4, 5, 6. B is 6'7". C is 3. And we want to know where D is. D actually has two different locations that it can sit at. D can either sit, if I'm drawing this parallelogram, this rhombus, D can either sit up here or it can sit down here. And that's actually an SOL question, and there's two answers to it, but you only have to give one. So how am I going to find out where D sits? So with this, depending on how you draw it, depends on where D sits. So I'm going to kind of show you both. So first, if I'm looking at it to sit above, and I'll redraw. All I need is a slope for above, because I know that, first of all, the opposite sides are parallel. So this side is parallel to this side. So if this side right here is an undefined slope, this side right here has to be undefined slope as well. So all I have to do in this point is count 1, 2, 3, 4. From here, my undefined slope, 1, 2, 3, 4. Point D can sit up there to make my parallelogram, or excuse me, my rhombus, like this. Because my slope, my opposite sides have to be congruent. So here, my slope is undefined, and here my slope is undefined. But my slope here also matches. My change of y over my change of x is 1, 2, 3 over negative 1, 2, 3. So it's negative 1 is the slope here. 1, 2, 3 positive, 1, 2, 3 negative, my slope is negative 1. So I do have my opposite sides being parallel. If I had chosen the lower point, that is not incorrect as well. So this first point here is what, 3? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So point D is at 310. Point D could have also sat going this way. I'm just going to do a different color so you can see it, because it's important, because the SOL test will ask the same kind of question as well. If I drew my parallelogram like this, then point D is going to be somewhere down here. 1, 2, 3, 4. It's still going to be 1, 2, 3, 4. And point D could also sit down here. Where, at this direction, point D would be at 3, 2. But my slope is undefined. My slope here is still undefined. And then here my slope is 1, 1, 2, 3. So it's 1 over 3, so it's 1/3. And my slope here is 1, 1, 2, 3. My slope is 1/3. Both points are correct. Your answer could be this, or your answer could be this. Both are correct depending on how you view the parallelogram when you're looking for the fourth point, excuse me. Fourth. All right, short answer questions to have us start thinking about some of our properties. You will have sometimes, never always questions, and you'll have to think about properties on your test. With that, here are some things you need to keep in mind. First of all, diagonals are always perpendicular in what figures? A kite, the rhombus, and the square. Now remember, when you have that perpendicular in the middle of it, who shows up to the party whenever I've got a right angle or a triangle formed? Correct. Pythagorean theorem or SOHCAHTOA. They can show up to help you find a missing side, or actually, well, not really a missing angle. It's not the angle with the 90 degrees. It can help you find a missing angle or missing vertice on the side as well. Because remember, inverse SOHCAHTOA can find an angle as well. Diagonals are always congruent in what figures? There's actually 3. Diagonals are always congruent in my rectangle. Diagonals are always congruent in my square. And we can add one more. Exactly right. The isosceles trapezoid. I don't think I spelled isosceles right, but that's okay. The isosceles trapezoid. That's one of the only other properties of my isosceles trapezoid is that my diagonals are congruent. Diagonals bisect. And we're going to need more than 2 blanks here as well. Where do my diagonals bisect? First of all, parallelogram. Then everybody else who is a parallelogram. So that would be my rhombus. That would also be my rectangle. And that would also be my square. All right, my angles bisect. My angles bisect when my sides are congruent. Then my angles bisect. My opposite angles bisect, and that is in my rhombus and in my square, because a square is a rhombus. An isosceles trapezoid, it has what 3 things? It has congruent legs. It has my base angles congruent, and then my diagonals congruent. Okay, if we have a right angle, we can use blank and blank to help solve for side or angle measurements. He's our friends from above. Pythagorean theorem. And my trig functions, or you can just put SOHCAHTOA. Know your quadrilateral flowchart. It tells you everything you need to know. So I have a little mini one right here. And as we were talking about with this quadrilateral flowchart, remember, going up the flowchart answers my always questions. A square is always a quadrilateral. A square is always a parallelogram. A square is always a rectangle. Going down is my sometimes question. A parallelogram is sometimes a square. It's a square when it has 4 right angles or the diagonals are perpendicular. Diagonals bisect the angle. That's when a parallelogram becomes a square. So it's sometimes. The never is when you have the disconnect. And this again should have a line to there because it is part of that. It does go to that. So with that as well, the disconnect, a square is never a trapezoid. A square is never a kite. So with that, remember the chart that we filled out in class, and you should be good on your sometimes and always questions. You have to know the properties of the polygons, or there's no way you can answer sometimes never always questions. So you've got to know these properties. Have a wonderful night, and thank you for joining me.